So next up is Chris, who's on the Ember Data team. He's going to give us a bit of a rundown about current state of Ember Data and what's been going on, and also follow up with an AMA. So hopefully got some questions for him. Over to you, Chris.
Today, I mostly want to do a quick run through of more where we want to be kind of by end of year than necessarily where we are right now. I'd say of what I'm showing today, the internal implementation is there for about 85% of it, and the external implementation is there for about 60% of it. And so we can talk about, what work still needs to be done if we want to at the end. I think there's kind of like three key things to really kind of center the conversation. The first is just a recognition that currently Ember Data is in this valley that Wycats likes to refer to as the pit of incoherence. It's the reason for additions in Ember more broadly was that when we go through periods of transition, a lot of times there's a period of time where we've introduced a lot of new patterns, but the story isn't fully baked yet. And so you have confusion because should you be using the new patterns or should you be using the old patterns? And these stories don't intermix well. And so we cut an addition at the point that we feel like the whole story is there. What I'm showing today is what we are hoping the Polaris story is for Ember Data. And so right now we're in the pit of incoherence, but the goal is to deliver a very coherent story by the end of the year. The second topic to kind of center this conversation is the evolution of Ember Data is going to feel very much like the same, but different. That really can only be best explained through example, and we'll be diving into that here in a moment. But there's been, I've sensed a lot of fear around a lot of the change that's been coming in RFCs, into documentation, around why are we doing this? What's the motivations? How does it fit? Isn't Ember Data working well enough? Why do we need to change it all? I think the last talk did a really good job of kind of setting up some of that. There's lots of reasons that teams have bailed on Ember Data. And then when they do, they often find that, hey, wait a minute, I needed something that was figuring out how resources were interrelated. I needed something that had a little bit of caching for my requests. I needed something that did a little bit of change tracking and updated notifications. There's a lot of stuff that it's handling for us that we aren't necessarily realizing that we're going to have to recreate when we bail. I think to assuage that fear, I want to show how the new world for Ember Data, where we're going, relates to the existing world, taking the best of what we have today forward while removing a lot of the barriers that have kept us from having a first-class experience for everyone. So everything that we do today has a corollary. There is a path in between, but it's just a little different and it's subtle sometimes. The last is I'm going to show what I'm showing today. I'm showing it from the perspective of JSON API. That's a very important caveat because it's almost a risk to do that. Not because JSON API is bad, but because Ember Data isn't JSON API. Historically, our cache implementation was a JSON API cache. Historically, JSON API, the spec grew out of Ember Data. But we aren't going the direction of JSON API in the future. We're going the direction of being agnostic to format. But even when you're agnostic to format, you have to work well with a format or with many formats. And one of those, the formats that we have the best support for currently is JSON API. So I'm giving examples from the JSON API perspective, but the takeaway here should not be, oh, Ember Data is doubling down on JSON API. We're not doubling down on JSON API. We are moving to a place where we're agnostic, and JSON API is one of the implementations of things that you could use. That wraps into a kind of a broader point, which is Ember Data is a multi-purpose tool. And because of that, it can be really hard to talk about. I'm trying today to show how to use it from a particular perspective. But that's only because I think we digest what a library is capable of by seeing it in action. But Ember Data is far more now than what I'm showing today. What we've really focused on is building primitives that are extremely powerful and really good at not getting in your way. When an allegory I've kind of been thinking about this is, imagine that Ember Data is a really good multi-purpose hammer, and you're going to the hardware store and you don't really know what hammer you need. You just know that you have a nail that you need to nail into the wall. And you go to the hardware store and you pick up the nail and you go to an employee and you say, do you know what hammer I need for this? And he goes, well, this hammer right here is really good. It costs, $30 and it's just going to last you a long time. And you look at that hammer and then you look at the hammer next to it and it seems like it fits the nail that you've got a lot better and it's only $20. And so you buy that hammer and you go home. And then you have another project to hang something else on the wall. You go back to the store, you get bigger nails, they're heavier. The lightweight hammer that you bought before isn't going to work anymore. You go to the wall, you look at the hammers that are offered and you go, there's that general purpose hammer again. But, honestly, I have a heavier nail. So I'm going to go buy this heavier hammer and I'm going to spend $20 on that. And now you've spent $40 on hammers when you could have spent $30 on hammers. I think we see this happen in tech a lot. When a tool is really good at doing a lot of things, people don't understand how they can use it and how it fits their situation. And since they don't understand how it fits their situation, they eject from that tool entirely and they will go get the thing that they think is more special purpose. You do that enough times, you're actually paying a higher cost. This is the goal of a good abstraction, is that it can handle lots of things at low cost. And that's what we're seeking with Ember Data. So with all this said, let's dive in a little bit. The way I want to approach this is, what does Ember Data do right now? And what does Ember Data do in the future? The right now, the old portion of this, some of the new portion has already been implemented. So, but what I'm going to show is always what people are used to doing, not necessarily what you can do now as the old. So to start, your first interaction with Ember Data is you probably installed Ember Data, or you ran Ember new, but imagine for a moment it didn't come in the blueprint. You install Ember Data, and what that ends up doing for you is it gives you a store service. We don't use a blueprint to add the store service though. It's, the magical V1 add-on. We re-export a service in the app directory, so you end up with a service in your store. But it's effectively this. In the new world, you wouldn't npm install Ember Data. You would npx Ember Data. The reason is that in order to make Ember Data flexible enough to handle really any case, we want you to select which parts of it you need, which tools you need, and we can walk you through that setup. So npx Ember Data runs an installation script, but it's going to ask you some questions. Like, do you need request management? Do you need caching? Do you need in-repo schema definitions? We'll get into what this stuff is, but it's going to walk you through that flow. It's going to walk you through, do you use REST? Do you use JSON API? Do you use GraphQL, Active Record, something else? And you're going to come out of that with, hey, these are the packages that we think we need to install and configure for you. Is that right? And you can make adjustments. What this does is it means that the out-of-the-box experience for Ember Data can be as good for GraphQL and REST and Active Record as it historically was for JSON API, without the cost of having installed a lot of stuff that you didn't need. Once you've done that, what happens in your application is the first big difference. Instead of it being an add-on re-exporting the store service, you're going to get two things in your app. Well, maybe just one thing. It depends on what selections you've made. But the minimum thing you're going to get in your app is a request manager, not a store. The request manager is a pipeline for managing fetch requests. So reasons you might want to do this is, hey, I need to add authorization headers to all of my API requests. It's really tricky to need to do that at every single place I call fetch in my application. Wouldn't it be nice if I had a service that I could call fetch and it always decorated it with authorization? This is an abstraction that helps you with that. It might be that you don't want to think about the transport protocol where it is that you're issuing the request from in your application. You just want to issue the request. So this is an abstraction that helps you with that. Like you can switch out between I'm using fetch in HTTP2 to I'm using WebSockets or I'm hitting local storage or IndexedDB. All the request manager is good at is managing a request pipeline. And you might be using it with fetch and you might not. The second thing that you'll get if you go opt for more of Ember Data than just request management is the store service. And instead of being a re-export, it'll do a little bit of configuration for you depending on those options that you selected. So in this case, we've imported the data store from the store. We've chosen to import hooks from Ember Data schema model. Legacy version of this would have been importing the same thing from Ember Data model, which we do via macros today. So you don't ever see this, but this is actually how Ember Data model integrates with the store today, is via these two hooks. So you import these two hooks and you say, okay, for records, I'm going to use instantiate record and tear down record from this package. For the cache, I've imported a cache from the JSON API version because I know that my data is in JSON API format. So I'm going to create a cache for that. So in the old world, we had this, and in the new world, we have this and this. It seems at first very verbose. I'm doing a whole lot of stuff that before I could just install and I was happily on my way. But the power of this is, hey, I don't use JSON API. Okay, I can swap the cache. Hey, I want a different model implementation. M3, legacy Ember Data models, this new schema model, something else. I want to write my own. I just want to use plain JSON. You can implement the hook this way. And you don't pay the cost of Ember Data having provided a default implementation for that. The next thing you probably do in the existing world is set up an adapter and a serializer. So you might run a generator to generate an adapter to generate a serializer. And in the JSON API world, this usually just means that you use the default JSON API adapter and serializer. In the new world, this was handled during the NPX, because that is a responsibility of the request manager, is how do I fulfill requests? And we're going to say, hey, use fetch. JSON API pretty much doesn't need more. But if you do need more, I think my example for this is at the bottom. Fun times. Okay, I was giving this presentation to someone else, and I think I removed the piece that I wanted to talk about. If you did want more, you would import the build operation from the JSON API package, and you import that only if that's what you actually need and want to do. What does this look like in practice? This is where this example breaks down slightly, because we've made a massive change. In the old world, when you issued a request, you did something like, say, call store.find record. So you might do this. And I know we haven't created a record yet. In the new world, we will instead call store.request and pass into it a request object. Now, a request object is really just fetch options, like MDN, Google fetch options, what's possible, with a couple of additional things to decorate it for cache capabilities. And if you're curious in what those things are, you can read the request manager documentation or RFC. This is one of the things that has shipped. But for the ease of convenience in the old world, that adapter would have built the URL for you. Today, we move the URL building forward to the point in which we issue the request. And so if you want to not think about how you build the URL and you just want to have the URL built for you, you would import find record from Ember Data. There you go. It actually knows that I was working in there lately. So you would import find record from Ember Data JSON API request, and you would pass into it exactly the same signature that you might have done in the past for store.find record, except now you're passing it into this method. And again, this method just returns to you an object. And so if you wanted to make any alterations over what the defaults were, if you even wanted to use the default builder, you could do that before you actually pass it in to make the request. This is a change, like from the ergonomics perspective, it's the same but different. This is what I mean when I say that. It's the same in the sense that we still think of this as, hey, go find this record. It's very similar in the syntax once you import find record and use it in this sense as a build operation. But it's different in that one is a slightly different syntax, but two, it unlocks a huge thing for us, which is that the URL and cache options are available from the first moment of the request. In the past, Ember Data could only cache by resource. And now Ember Data, because of this change, can cache by URL or a cache key on the cache options, in addition to caching by resource. What that means is that, say you have one place in your application that you were calling find record for user one, that you wanted to include your pets, and another location where you didn't, you wouldn't need to call reload anymore. Because the URLs for those two requests are unique, they are separate cache entries. You will still get back a single resource for that user, but the request would have been issued because Ember Data would understand, hey, I have never seen this particular request before, so I'm not going to fulfill from cache, I'm going to hit network again. This makes Ember Data work really well with lots of paradigms like gRPC and GraphQL and JSON API. It also means that there's more than one way to go achieve things like partial record support. So for instance, if you wanted to say, hey, I want a mini user that is only a subset of fields because I don't need all the data, then you could actually still use the user record for this, as long as your URLs for where you fetch the user specify which fields that you actually needed in the one versus the other. And that's not necessarily the best way to achieve that feature, but it's a possible way of achieving that feature. But back to old world. Old world, after you got your adapter and your serializer set up, you probably generated a model. So Ember.g model. If you were looking for some polymorphism or some shared traits, you probably used a mixin. Like, for instance, here we've added likable, which locks you into classic syntax. You have some transforms, which a key thing here is that transforms run in the old world, transforms run between the cache and the API. So they are a serialization and deserialization concern when going from cache to API. We'll come back to this in a moment, but that's been a source of confusion in Ember Data for a long time because people try to think of them as types and verifications or validations. But in order for them to be those things, they need to run between UI and cache, between presentation and cache, so that they are intercepting mutations, and they don't run at that point today, but we're changing that. You might do something like get full name. You might do something like started on, where you create a new date out of start date and start time. You might have some relationships, for instance, our pets. In the new world, you're going to npx Ember Data, generate a schema for a user. Now, this is optional. And this is another one of these things where like, I'm showing you one way of doing this, but we've built a toolbox that will work with really anything. The idea here is that one of the powers of Ember Data has been that it works really well with APIs that don't have a spec. If you do have a spec like GraphQL, you probably just decided a long time ago you were going to use Apollo, for better or for worse. You might have chosen to use something like TRPC at some point or protobuf at some point. And each of these comes with mechanisms for having a spec for what data you're receiving and having type signatures for what data you're receiving. But a lot of REST APIs don't have this. Or you might be a big enough company that you've built it, but if you're at a small company or you're consuming an external API, you probably don't have a spec for what your API is capable of giving you as a resource or as an endpoint. Schemas are a plug the gap mechanism for this. You might use GraphQL or TRPC and still generate schemas, but the likelihood is that you won't. The likelihood is that you will use schemas when you don't have access to those things in your tooling. Schemas don't live in your app. They live in your project, but they're not part of your app's code. They are written in TypeScript, but it's done this way as a DSL for how to author it. There is no runtime code here. So there's a schema parser that I've been working on that does this for you. And what the schema parser does is it understands what's possible in the file from the TypeScript perspective and then in the JavaScript perspective and what certain decorators mean. From that, it creates four things. The first is a JSON schema, which the store uses to understand how to present your data from cache. The second is TypeScript declaration for a read. The third is a TypeScript declaration for an update. And the last is a TypeScript declaration for a create. Because we look at these as being unique scenarios where you actually want different type signatures. And so by composing with the schemas in this way, you're getting access to really nice type hinting that's contextual based on what you're doing, not just one signature that tries to handle all of those situations all at once. And you get these schemas. This all runs at build time, not necessarily when you run Ember build. Like this is something you could just have as a separate project that when you make changes, you update your compiled output. And the way that Ember Data internally works with the schemas is that it accepts a JSON schema at any point until it needs it. Meaning like it's just in time in nature. By being just in time in nature, you can deliver schemas from your API. You could fetch them as a separate request. You could include them in the original bundle. It's up to you. All that Ember Data cares about is that if it needs a schema, which it doesn't always need a schema, but if it needs a schema, that it was present by the time it needed. And the benefit of it producing JSON is that it's very easy to transport that in any mechanism. So if you're using something like GraphQL or TRPC or just protobuf or whatnot, the schemas that those things generate, you would just need to have something that transformed those schemas into the schemas that the store understands, which sounds like more work than it is. One, it's probably a pretty easy transform if you did need to transform it. And two, if you're using a format like that, you're probably using a cache that already speaks that language, which means that the schemas that you already are producing for those technologies are what you would give to the store. You don't need you don't need to transform it at all. So same, but different. Here's a couple of the things though. This isn't just like a one-to-one transformation. When we move to the schema model package and when we move to using schemas in Ember Data, it's going to unlock a huge feature set. The first is traits. So likable is no longer a mixin. It's just, hey, I'm a set of traits that it can compose with the class. The next is that if you were to say, use a transform, it runs in between the presentation layer and the cache. The cache is in an always serialized state. The presentation layer is the hydrated state for presentation. So if you wanted to say have a date instance or a Luxon instance, that isn't what you would be storing in the cache. You would be taking the string form that's in the cache and hydrating it for presentation. And if you mutated that, you would take the new value and convert it into the string for the cache. This gives you much better TypeScript support. More importantly, it also fixes the mental model here of when transforms run and what they do. The has many and belongs to go away because they always had this weird sense of ownership when they don't necessarily own. Like has many doesn't necessarily own its membership. It might be a many to many, it might be a many to one, it might be a many to none. Same thing with belongs to. So instead we move to the terminology of resource and collection. Its definition and capabilities are similar only on the surface. Under the hood, what we're doing in the cache is very different because we will paginate collections by default in the cache. When you access a collection or you access a resource, there is no longer a distinction between synchronous and asynchronous relationships. All relationships are synchronous access of any data that is immediately available, and all relationships have the ability to be fetched, but no auto-fetch behavior. So accessing an async relationship and having that trigger a network request is a thing of the past. What that relationship looks like, for instance, for a collection is basically something a little bit like this. You have something that has pages, which is a map, and each map is a key, which is the URL for that page, to a collection. Collection is something was introduced in 4.12 for Ember Data. If you're using the request API and you get back an array as the primary data, you get back a collection. So a relationship that's a collection relationship is actually a collection of collections. We were paginating out of the box, but its data member is going to iterate that and reduce it into one array, similar to how you're used to working with collections today, or used to working with has many today. What's nice about this is that means that you can choose to work with the relationship as if it's all the data all at once, or you can choose to work with it in a paginated form. It's up to you. There's also something really, really powerful here that's just hidden and hand waved away, which is that because URLs are the keys for these documents, you can have different perspectives of the same relationship active at the same time. So for instance, let's say that I wanted to have a relationship that was sorted by some key and have that be paginated. Well, if I call fetch on the relationship, it's going to take any fetch options and apply them and treat the result as a new page. So as long as your API and your request manager are capable of describing how that page fits with other pages, which JSON API does out of the box with its links and pagination links, then what you can have is you go to a relationship and you say, I want on this part of the page, I'm going to be iterating this relationship from the perspective of sorting ascending on this field. And on this part of the page, I'm going to be doing the same relationship, but sort of descending on a different field. And you would not end up in a state of incoherence like you would today, where you're doing things like wiping the full relationship for each query or ejecting entirely into it not being a relationship at all. So relationships are kind of just like pointers to documents, and then documents manage their membership. The last thing in this is derived. When you give up having model classes, you give up the ability to do something like, hey, I need to calculate full name from first name and last name. The solution for this is that most of those computations probably never belonged living in your model. And so you ought to move it to a component or somewhere else in your application. But for the ones that truly are universal to the resource and should always belong to the resource, you can declare it in your schema as a derived field. This makes it easy for your API to also understand what these derivations are if you need to. And it also just makes it pretty flexible in terms of like you choosing where the best place for is for certain kinds of work to happen in your abstraction. Say though that you really just love the heavy model approach and you want to have tons and tons of computations on it and you don't want to mess around with derived schemas or anything like that. Well, instantiate record is the thing that instantiates the class and talks with the schema and gives you what you want. And you have the option to do that for every single thing, which means that you implement this hook, you go, oh, the record implementation that I want is something like legacy model, which allows me to do this, or maybe an updated version of it that allows me to do this on a per type basis. You could even, the way that we're going to build schema model, you could even extend schema model on a per type basis, where you get all the behaviors that we're describing for schema model, and then whatever derivations you've added to the class that extended it. So there's no one blessed way. These are all good options. And the idea is to just let teams figure out what the right patterns for working with data are for them. And finally, to kind of put some of this together, I showed this a little bit above, I guess, but you know, what does this look like in practice? Well, in the past, you might do something like find all user, or you might do find record user. And now you'll do await request with a find record or await request with a find all. There won't be an import find all. There will just be a kind of an import query. The reason for that is that find all is a pattern that we do want to discourage. If you want your query to return everything, that's obviously very easy to do. You just have your API endpoint return everything for that query. That's effectively what find all has always been. But building applications from the perspective of give me everything and then have it synchronously available and then filter and sort off of that, we repeatedly watched teams build from that perspective end up in massive amounts of debt as their application grew and scaled. The talk that we heard just before this one seemed to have that as an example as well of, hey, we fetched all of the data because it was so convenient. And then we discovered we had problems. So we actually want to encourage folks to use things that have the perspective of pagination from the beginning. But obviously, if you don't paginate, that's still okay. Like it's just going to give you back a collection when you query, and that collection will happen to have everything in it. Okay, so I think that's the whirlwind tour of the old to the new. A few things that I kind of glossed past in the schemas is things like deep tracking of dirty state are possible within the schema architecture and the schema model. Not only possible, but when we do put up the RFC for what that looks like, it will be included. It is in the design. The other thing is that's in that design is partial record support. So out of the box, we're going to have a concept of partial records. And we're also going to do deeply nested relationships. So if you have an object that, you know, if you have a resource that has an object on it that has an object on that, then in there's a property that is a reference to another resource, it'll be possible to model that as a normal relationship in your schema and have it managed the same way. Cool. So that is whirlwind tour. And let's shift to questions.
Yes, awesome, Chris. First of all, thanks a lot. I think those was very interesting. I think people can tell it's different, but still in a way same, right? So please post questions in the Zoom Zoom chat or ask questions if you're here.
Hey, how are you? So I know when you were saying the npx Ember Data install thing, you were saying you can opt into a lot of the features that were there before. What does it look like to kind of like automatically convert old stuff to new stuff? Is there a way to be like, oh, actually, people are using standard functionality as of like the quote unquote old way? I know it's not quite what it is in 4.12, but like the stuff that's in the guides. If somebody just touched what's in the guides, could we automatically convert them to the new stuff and give them all these new fancy features?
Eventually, I think we can. I think we're in the pit of incoherence here, where there's pieces of that story that we want to have provided ourselves that you could do without, but which we want to make sure are there, that would make that easier. An example of that is the URL builders. Right? That's one of the things that's been nice about, hey, just I've got an adapter that inherits from the REST adapter, or inherits from the JSON API adapter, I dropped it in, is that people just didn't ever think about how they were constructing URLs. I don't want to lose some of the ergonomics around that as part of the quick out of the box experience. Obviously, if that's not the URL building you want, then I want it to be easy for you to do your own thing. If you just want to treat it like fetch requests and hand type URL on each object as you call a request, you could do that. But that sort of thing, I think, is almost table stakes, like nice, little sugar to make it feel very familiar, and also to be very helpful. In terms of interop, though, I think the interesting thing about the approach that we've taken is it's a lesson we learned at LinkedIn when we built M3. How do you migrate a really large app? It's very complicated, from using one paradigm with Ember Data to using a different paradigm with Ember Data. So we built interop. We made it possible to run multiple versions of what models are at once, and multiple ways of requesting data at once. I've taken the learnings from that and cleaned it up and made it even easier to do that now. So if you, say, are using more of the legacy Ember Data patterns, and let's say that we've shipped schema model and it's available, well, you would implement instantiate record, and on a per model basis, as you've migrated, you just kind of use a map of what have I migrated versus what haven't I. You instantiate the new thing versus the old thing. In similarly, for request management, if you make a request via any of the legacy mechanisms in Ember Data, it's going to have an opcode associated to it. And it's going to, if you didn't pass in a URL, then it's also going to automatically have a symbol attached to it that marks it as a legacy request. We do a sneaky thing of the cache handler inserts a handler into the request chain that comes at the beginning to handle legacy requests. So if you have adapters and serializers, the way that's actually implemented is via a legacy compat handler for the request manager. And the way that it knows that it is the thing that should be handling the request versus just passing it along to whatever you've implemented, is it looks for that symbol and specifically. So that's not, what that means is that you can not only migrate on a per resource ability, but you can migrate on a per request capability. So if you're in an application today and you've gone way down the rabbit hole using Ember Data and it's very large and very complex, it's not all or nothing. You don't need to feature flag tons of parts of your app to go from A to B. You set up the infrastructure to handle a new world alongside the old world, and you can incrementally start fixing. All that said, I think we can code mod most things for most people. For instance, if you're calling store.findRecord and having a code mod that says, hey, I used to use the JSON API adapter. Can you convert everything from store.findRecord to store.request with a find record operation from the JSON API request package? Then that's totally something that builds. I don't know that we will have anything like that shipped for the Polaris experience unless the community steps up on it. But it is possible. I think that answers your question. If there was an aspect of that I missed, let me know.
We do have another question in the Zoom chat here. You mentioned that there will be different types to read, to create, and to edit data. Can you show the example of that?
Yeah, I don't have an example I can pop open quickly, but I'll explain what that means. Ember Data is moving to immutability. So when you get back a request, the response is immutable. When you peek record or find record or anything like that, the response is immutable. If you want to make a change, there's going to be two mechanisms for this. They're actually the same mechanism under the hood, but they have slightly different ergonomics. One is a schema model will have a method called checkout. And if you call checkout, it's going to return to you a new model backed by a fork of the cache that is mutable. And so at that point, you get a edit version of the TypeScript signature for that model versus the read version. Similarly, if you've called store fork, any record that you access via the fork, if you call checkout on it, similarly will have the edit signature instead of the read signature. The difference though is checkout is, and this is subject to change, but right now the thinking is that checkout for the main store results in you utilizing kind of like a persisted fork for immutability. If you call checkout on a record that was received from a fork already, it's referring to that same fork and just giving you the mutable copy for that fork. This prevents you from having too many forks of forks as you go down. And the last signature there is the create signature. If on any store, if you call create record, that gives you the create signature. So it's something that's mutable and it understands that fields might be absent and whatnot. The last piece of all this, and if you're curious, store forking was something that was RFC'd in Cache 2.1. No cache implementation implements forking yet, but the underlying mechanics of the store are there to support it. So that's something that we are hoping to get into Ember Data's default cache implementations by the Polaris edition. The hidden subtext in all of that is when you're using the request manager for requests and you save, we no longer have a concept of snapshots for serialization. Instead, we give you access to the cache and a list of records to be saved. That's possible because if you have a fork, historically transactions have been hard in Ember Data. Like you want to edit multiple records at once and probably save them together. What this gives you is instead of saving the individual record, you can still do that and it will send only that record to the request manager to be saved. But instead, you can save the whole store. And it will take the full diff of that store versus the parent store and give that list of records to the request manager along with its version of the cache to the request manager for you to go and persist. So you'll end up working with the cache a lot more directly, which actually has better ergonomics than snapshots did in a lot of ways. And you'll end up working with lists of records and being able to be transactional about it.
Thanks, Chris. It was great to get that insight into what's coming in Ember Data. And I think that ends the event then for today, right?